Hello?
Hello. Yeah. Can you hear me? Hello. Hello.
Hello?
Yeah. All of you can hear me, right?
Yeah,
Okay. Before the break, we had just started number bases, right?
yeah.
Uh, we had done one or two questions, I think. I don't know if we have done the question.
Hello?
Adam, Noah, can you hear me?
Lower?
Uh,
Can you hear
Adam, can you
me?
hear me?
We can hear you too.
What's that sound?
I can hear you.
How good, how good?
Hello?
I can hear you.
I can hear you now. Okay.
Okay. Okay, fine. So we were looking at number bases. We had done a little bit and we had done one question. I remember there was a question with the answer 397 and all and 669, where we were finding a number, smallest
Oh,
three-digit number that is equal to the sum of its digits plus twice the product of its digits, right?
yeah, we did that one.
So we'll do some more questions and then we'll continue. Like basically one or two more classes. I need to discuss certain types of questions. I think I had given a list of questions also,
Um,
but you might not have tried it, right?
Um,
Okay, we'll look at these problems today. Digits A and B, so that the 15-digit number, the number is 7A, 7BA, 7AB, 7BA, 7B77. This 15-digit number is divisible by 99. We have to find 10A plus B. I hope the question is clear to everyone.
Yeah,
yeah.
Think of the divisibility by 99. If you think of 9 and 11, oh, is it 99? Yeah, 9 and 11.
I think I have it because
What is the answer you get?
I'm getting 53.
That's correct. Explain what you're doing.
So if you look at the divisibility by 9,
Hmm.
then um,
Sum has to be divisible by 9.
yeah, so you add all the digits.
You're
Um,
getting 49 plus 4a plus
plus
4b.
yes, and then you can just make the 49 equal to 4 since it's in mod 9,
Hmm.
and then um,
This has to be 0 mod 9 somehow.
yes. So
So,
then you could just divide the whole thing by 4, and then you get that a plus b plus 1 must be congruent to 0 mod 9. And that means that a plus b must be congruent to 8 mod 9. That means that a plus b can either equal to 8 or equal to 17.
hmm. Okay.
Then I looked at then I just looked at the divisibility by 11. So it's like you add all the even place digits and
Hmm.
you like, you add all the odd
Subtract.
place digits and subtract all the even place digits. So,
You'll get 7
um,
plus 2a minus 2b.
yes,
Should be 0 mod 11.
yes. Then, um,
So this has to be 4 or minus
4,
7,
yes, I made it
right?
equal to 4, and then I divided the whole equation by 2
You're getting
to get
a
that.
plus b can be, okay, a minus b can be 2 or minus 9, right?
Yeah, wait, yeah, 2 or minus 9.
Because minus 9 into 2 plus 18 and 7,
I don't think
25.
it,
It
I don't think
works.
it can equal minus 9 because they're digits. Oh, wait, A can be 0 and B can be minus 9.
B can be 9, A
Um,
can be 0.
and then,
Do you see that a minus b is
um,
minus 9 works for the whole thing? It can be 4 mod 11, right?
oh,
With the value of minus 9 here, you'll get 18 plus 725, which is working out.
yes, I
Obviously, 2
see. Oh,
will
I didn't
also
even,
work.
yeah, I just did A minus B equals 2. I didn't realize A minus B could be equal to minus 9.
Maybe the solution doesn't come because of the other thing, but where you have to
Yeah,
do,
because,
so you have to solve a system of equations.
yeah.
If you
And
solve the
then
first one, you are getting what? If you do a minus b,
the first one you're getting, if you do equal to negative 9 and 8, that can't work because A would be a half or negative a half. And if you do A minus B and
basically
if
both
you do
have to be
negative 9 and
even, or
17,
both have to be even, or both have to be odd,
yeah,
right? Adam, you are getting it, no?
Yeah, I understand.
53 will be the answer finally.
Yeah.
Okay, let's move on to the next one. Find the least positive integer of the form ABAABA, where where A and B are distinct digits such that the integer can be written as the product of six distinct primes. Think about the structure of this number.
Yeah.
This
Yeah,
is
I think
like ABA twice.
Hmm.
If you look at a 3-digit number ABA and call this as N, then see, this is 100A plus 10B plus A, right?
Yeah.
So actually what you have here is this number is 10 to the power 5A plus 10 to the power 4B plus 10 to the power 3A plus 10 to the power 2A plus 10B plus A. This is
Yeah.
actually N, and this is 1000 times N, right?
Yeah.
yeah,
So the number that you need is actually 1001 N,
Yeah.
and N is this for now, right?
Yeah.
So think about it. 1001 itself is 7. It is divisible by 7. It gives you 140 and then 980, 143. 7 into 143. So that is basically 11 into 13.
Yeah.
So we are already able to write it as 3 primes multiplied by n, right?
Yeah.
Now you just have to figure out how to make it 6 primes multiplied by n.
um,
The smallest way to build your n, right?
Hmm.
I don't think it is so difficult now.
No.
yeah,
But you have to make sure that all the primes are distinct, and also you have to be a little careful.
Yeah.
It's still not like super obvious or something. You have to think a little.
Yeah. So you have three prime numbers multiplied to A.
Are you getting something, anything?
Mm.
See, you should
Um,
start by thinking this A, you can take cases of A because ultimately A can be from 1 to 9 only, right?
Yeah.
If I take A is 1, then you will realize that this whole number will end with 1 also,
Yeah.
correct?
Yeah.
So then the overall number is odd, right?
Yeah.
So then this number also has to be odd, the n, right?
Yeah.
yeah,
So it must be n is an odd number. That means it's a product of three odd primes, right?
Yeah.
Which cannot be 7, 11, or 13.
Yeah.
So the smallest possible ones are 3, 5, and 17, right?
Yeah.
Which is basically giving us 255 for small n,
Yeah.
correct?
Yeah.
Uh,
yeah,
but that is not possible for a three-digit number starting with 1, right? Again.
Yeah.
See, the product of primes, the smallest possible product is 255. But if you put A is 1, you cannot get a number like that, right?
Yeah.
yeah,
Because this three-digit number also should be n, correct?
Oh, yeah.
It's not just that is a n has to be this three-digit number also, no?
Yeah.
So this doesn't work out because this is too small and 255 is too big, right?
Yeah. Yeah.
Then we start looking at A is equal to 2 maybe, right? If A is 2, the number is even, right?
Yeah.
Okay. Then one of the prime factors of that number has to be 2, right?
Yeah.
yeah,
And think about it. If 2 is one of the prime factors of ABA is equal to 2 into something, 5 cannot be the other prime factor, right?
Oh, yes. Yes.
Because then ABA will end with 0, right?
um, yeah,
So you cannot put 3, you cannot put 5, you cannot put 17, right? So
yeah,
obviously, what about no, no, I am making a mistake. You cannot put 7, 11, and 13, right?
yes, yeah,
This was a different case. So 7, 11, 13 you can't put. 5 you can't put because it may get end with 0, right?
Yeah.
So then the next smallest prime number is 17 and then 19, right?
Yeah.
Smallest product will be 646, right?
Oh, yes.
But then again, 646 is too big for ABA where A is 2, right?
Yeah.
Do you understand how we are eliminating cases?
Yeah.
Okay, so fine. Then uh, then we can take A is 3. Wait, is any other possibility for 2 there? 2. Wait, wait, we forgot. We did not check 2 into 3 into something, right?
Oh,
Right, we only check this
yeah,
case. We have to check 2 into 3 into something also, right?
hmm.
So mm, let's look at a prime that is a product of 2 into 3 and also another prime such that the number is also looking like 2b2, something like this, right?
Yeah.
So this is already giving us 6, right? And 6 into some prime should be equal to something in this range, right?
Yeah.
Correct? So
Yeah.
obviously this b can be anything bigger than 0 or something, right? It can be 0 also. So your prime is such that it is 202 up to 292, right?
Hmm.
So P range we can get, no? P will be lying between this by 6 and this by 6, right?
Yeah.
Yeah.
So you can sort of now get the value of P is like 33 point something to this is 240 to 300 would have been 50. So this is like 49 or something, right? 248, right?
Yeah.
So the primes between 33 and 48, the only few options will be there, 37 and 41, right?
Hmm. Oh,
Right.
43.
43 also and 47 also.
Yeah.
37, 41,
Yeah.
43, 47. And if we check the products in those cases, 2 into 3, 6 into 37, that will be 222, right?
Yeah.
Then 6 into 41 will be 246, right?
6.
6 into 43 would be 240 and 6, 258, right?
Yeah.
And finally, 6 into 47 would be 282, right?
Yeah.
And now this is the only number that looks like ABA.
Oh, yes. Wait, what about 222?
222, if you put, then B is also 2. The whole number is 22222, right?
Oh, yeah. They have to be distinct. Yeah.
It has to be distinct
Yeah.
primes, they have said, right?
Yeah. See.
Because A and B, 222 is what? 2 into 3 into 40 thing. But wait, A and B also are supposed to be distinct.
Yeah.
Primes were distinct, but A and B also are supposed to be distinct.
Yeah. I see.
So a little bit of like thinking, because how to make 6 primes? You cannot start by writing this as the full number. You have to see this pattern that it is repeated.
Yeah.
If you don't see that repetition, then it will be difficult, right?
Yeah.
Yeah.
Once you see the repetition, one part of the problem becomes easy because 1001 takes care of 3 primes. And now you have to think about how to make this number product of 3 primes, right? And it's not like there is some standard way to approach it. You have to figure out a way to cut down the number of possibilities easily so that you don't have to do random casework, right?
Yeah.
The way we did that here is we started off with, okay, A can only be from 1 to 9. So if you put A as 1, and then we started checking what is the nature of the number ABA? How many primes can we multiply to get it and all, right?
Hmm.
What are the smallest 3 primes which will give us product ABA? When we tried it, we got a number like 255 is the smallest, but actually,
Yeah.
if you put A as 1, it is already very small, right?
Yeah.
So it's like that we were eliminating the cases. Here we forgot about 2 into 3 because we only saw 217, 19 earlier. But 2 into 3 you have to look at. And then we were
Yeah.
able to get a range for the third prime.
Yeah.
Ultimately, it's common sense only. It's not like there is some process by which you can do it. You have to figure out based on thinking.
Mm.
Okay.
Yeah.
For positive integer n, S of n is the sum of the digits of n in when n is written in base 10. 10 in base 10. Okay. Find the sum of the two solutions to the equation n minus 3 times s of n is equal to 2022. Any progress?
As it was, if we write it out as like 997,
900. Why 900 and all?
because I'm assuming n is a four-digit number.
We can't assume such things. I mean,
I kind of showed that it's only 4 digits.
how?
So if so S of n is positive, so it must be at least 4 digits, and then
Wait, S of n is positive. It must be at least 4 digits.
so n must be at least 4 digits
Right.
because
Okay.
well, n is actually greater than 2022, you know, but
Yeah.
yeah. And then when n has 5, so if you look at the cases where n has more than 4 digits,
Hmm.
you can say that n is at least 10 to the power of k, 10 to the power of x, and then the 3 times s to the power of s of n is at least, wait, s of
S
n
of n is at least greater than 1 then.
I said s of n is at most 10 times x.
S of n is at most 10 times
For any
x.
n, for any weight.
I don't understand what you say.
Wait.
Maybe you are saying on the right track, but
So for any, if n has x digits,
see,
s
S
of
of n will be less than equal to 9x. No? If n
yeah
has x digits,
yeah,
right?
and then you have that 10 to the power of x minus
You can say n minus S of n will be greater than equal to 10 power x minus 9x.
yeah, well yeah,
See, this is the maximum value of the subtracting part, and this is the smallest value of the positive
yes,
thing. So definitely the difference is greater than this rate.
yeah, and then
And this thing, what can we say?
so if you try x equals 5, you get that it's way bigger than 2022, and then you have that 10 to the power of x increases exponentially while 9x increases at a constant rate.
So basically n minus S of n for now is coming as much bigger than 2022. So there is no
Yeah.
solution for x is equal to 5.
Yeah.
And it cannot have solution higher than that because this difference will be even big.
Yeah.
Right? Okay, so
Yeah.
now we know that it has only 4 digits, n. But Noah, you have to prove it, you cannot assume it, right? If you assume it, you'll lose points. Right? Okay, so it has 4 digits, so now what?
You can just say 997A plus 97B plus.
Wait. Why are you getting 97 and 997? No?
Oh, sorry. If you let n equal to 1000A plus 100B plus C plus 10C plus D as the four digits, then you have to subtract 3A plus B plus C plus D to equal 2022. Then you get 997A plus 97B plus 7C minus 2D. Then the thing you can notice is that
1 second.
B can
1 second. Okay, are you getting something?
Yeah. So I said like
Hmm.
you must notice that 97b will always be less than 997, and that 7c will always be less than 97, and that negative 2d will be always less than 7. So then
Negative 2d
because
will
of
be always less than 7.
yeah,
Like, why are you saying this right now?
because this means that a has to equal 2, because if a is less than 2, then
Mhm.
like the rest of the numbers won't be able to add up to 997 to give you the 2020. Then
Okay.
um
If A is
and
1, you
then
are saying it will not work.
yes, because the rest of the numbers, like
Hmm.
even at their maximum, can't add to 997.
Okay. It is true that this digit B can be 0 or 1, I think.
Oh no, wait, it can't be one.
Why?
One, oh wait,
Because if
yeah,
you
it
have
can't be one, it'll be too big. Even if
997 times
B,
2, you subtract that from 2022, you'll get
Hmm.
97b plus
So it can't be
7c.
1, it has to be 0.
Yeah.
yeah,
And then
then you're
C.
left with, then you say 7c minus 2d has to be equal to um
Minus
28.
1994, right?
That gives you 28.
Mm-hmm.
Then from there, I just said that you can get c equal to 4 and d equal to 0. That's like the obvious solution. And
Mm-hmm.
then obviously c needs to be even because of the parity.
Mm-hmm.
So c equals 6 and d equals 7. And if you try c equals 8, then d must equal 14. So that can't work.
So you're getting two different values.
Yeah.
These are the two numbers you're getting, right?
Yes.
Okay, fine. So again, basically it's about thinking creatively, figure out what constraints are there in the problem and how to use them, right?
Yeah.
Okay, I'll give you a few problems for Sunday. Try the now you guys have time, right?
Yeah.
Yes.
Try these questions out. Uh, they question. I think I had already given this question before, but now you can work on it. This is a 6-digit number is equal to DEF, and different letters represent different digits. Different digits. You have to find A, B, C, D, E, F. Then the next one is find the smallest natural number whose square ends in 2016. I hope you understand the meaning.
Yeah.
Px is a polynomial with non-negative integer coefficients such that P of 1 is 4 P of 5 is 152. You have to find P of 11. Okay, so these 3 questions you can try for Sunday. Okay.
Okay.
We will do these solutions and then we'll do some more problems. And then one more class after that we'll need for this topic.
All right.
Okay, so I anticipate like 4 or 5 more classes. Then we will start with a different topic. We'll do algebra or number theory or geometry or combinatorics, something else.
Okay.
All right.
So work on it and see if you can figure out these questions. We'll continue on Sunday. Also, are you guys doing the AOPS Woot program?
Yeah.
This one?
Yeah.
How is it?
It's quite difficult. I I think we stopped a bit for exams, but we can catch up now that we're free.
But the lectures and all are how are they? Are they good or what is it like?
They are good.
Hmm. So you guys get video lectures from AOPS,
No, I believe it's text
but
lectures.
it's text, okay. So in the class, if you
Yeah.
attend, you can chat and talk to them.
Yeah, but for us the time is very bad, so we just get the
Transcript
script
later.
of it. Yeah.
And what about the problem sets?
They are quite challenging.
But that you get as a PDF or something.
Yeah.
Yeah.
Okay, why don't you share this? I want to see it.
All right.
If you have some problem sets that you've gotten from here, I want to see it. Just share it once, no? If you can, if it is possible
Yeah.
to share.
Yeah, I can see.
Right.
We can
Because
see.
like it's an expensive program. I want to see how they are designed and all. The problem sets I want to see.
Yeah.
And do they discuss the solutions later or no?
Not for all the problems. I think like for only one problem. So they'll have like one problem. So like every week they'll have like 10 problems,
Hmm.
and they'll like mark one of the problems.
So basically they will discuss only one of them.
Yeah, but they'll like mark your solution.
Oh, they will grade your solution basically.
Yeah,
But what about the others? That those you have to do.
yeah, those you do by yourself, and I think it just tells you the correct answer if you get it wrong.
So it's like an online platform where you input your solution or what?
Yeah, you input your solution and then it'll tell you if it's answer right.
Okay, but the problem sets are a little challenging.
Yes, yes.
Okay, fine. But it's text only and like it's not like people are talking to you or something, right?
No, they don't. I don't think they have like video lessons.
Yeah. Okay, if you can share some problem sets, I would like to see, but otherwise it's fine. Just focus on our classes and we'll cover everything that they need. Okay.
Oh,
Number theory will be roughly finished. We can come back to it later. We'll cover whatever you guys find difficult, geometry, algebra, whatever.
okay.
And keep your focus on the Pan-African Olympiads and we'll worry about that only.
Okay.
Okay.
Okay. And now you guys have a lot of time, so please practice and let's make progress fast and let's work on
Okay.
it after every class. Don't ignore the problems. Okay.
Yeah.
Okay, that's all for now then.
Okay. Thank you.
Bye.
Thank you.